Okay, so I want to try to explain it one more time. So imagine a wave, right? That's just like a wave in water, a wave in anything. It's if you were to spin a string, you got a string on your hand and you wave up and down, up and down, up and down, the string's gonna make this shape, right? And that's the shape that waves do and everything. And so if you imagine that the surface level of the water of your lake is zero, right? And then you've got waves, you've got the part where the water goes up and the part where the water goes down. Plus one, minus one, plus one, minus one. And the wave is moving this way. But really it's the energy that as the water here is pulling up on the -1 and then it runs out of energy at the top, right? And then it's loses its energy to the other side, so that the thing it's doing this, right? And if you were to have a second wave where you got someone else is holding the other end of the string and is also moving up and down, right? So you're holding on one hand, you're spinning the string up and down, and someone else on the other down, up and down. If you were to add up the energy of those two systems, right? And let's say that they're moving up and down at the same frequency. They're moving up and down at the same frequency. If one hand is up at the same time as the other, and that it equalizes in this way, then depending on the length of the string, whatever, bad example, but depending on how you're shaking your hands around or how the waves are moving, right, then you have one of two outcomes, right? Either the two waves are at the same time, right? So the bottoms are adding together and the tops are adding together, or they're a little bit out of phase with each other, and the +1 and the -1 lines up, and the +1 and the -1 lines up, and the +1 and the -1 lines up. And the two possible outcomes of that are just a straight line where you actually have two waves, but because of the way they are, it's just surface level on the water the whole time, or because of the way you're shaking your things, right in the middle of that string, it's just going to be a straight line, even if they're moving their hands up and down on either side, because they're canceling each other out perfectly. Or they're amplifying each other such that there's a +2 and a -2 and a +2 and a -2. And the thing that's cool about that is that every single force in the universe, every single particle can be described as a wave in this way. So you got an atom here, you've got a negative atom here, you've got or a proton and an antiproton, and a proton and an antiproton, or an electron and an anti-electron, a positron, right? Like all the particles in the universe are like that. And the vacuum of space looks like this. That's what the vacuum of space is. Everywhere where there's nothing, you look at somewhere in the universe and you're like, there's nothing there. It's because there's not actually nothing there. There's just waves interfering with each other that it looks like zero. But really, everywhere in the universe is like this lake, this surface of the lake, and there's energy thrumming there. There's a 0 point energy that it's not actually zero, but it looks like it's zero. And as far as we can tell, it's zero, and it's basically zero, but it's not zero. And if you were to tug on one end of this zero energy, right, you move it a bit, right, suddenly particles appear in that space from nothing, because they were always there. And it's just this symmetry, asymmetry. And if you just play around with that 0 point and you move around with the symmetry, if you accelerate in one direction, it starts to look like this instead of like this. And anyways, I hope that explained it a little bit. I don't want to keep blurring your brain, but I want to overcome the difficulty of explaining this very complex topic, and to help you understand, because I do think it's like fascinating and super